If I had to simplify this, let's not put x, let's put this. What would you say this is on the first slide?
5 to the power of 22.
Nice. And you got this how?
I added the indices and didn't change the number.
Nice. Yes. And what about this one?
Would it be 4 or 5 to the power of 4?
Why is that?
I did 2 add 10, which is 12 divided by 3,
Okay. And why did you divide by 3?
because it's divided by 5 to the power of 3.
So when you had 5 to the power of 2 times 5 to the power of 10, what did you do with the powers?
I added them.
So now that we're dividing, what do you think you should do?
Subtract.
Yes. So rather than taking away, rather than dividing, you would subtract indeed. So that being said, what would your answer be?
5 to the power of 9.
That's it. Cool. Okay, still sticking with this topic and theme of fives. Um, as a power of 5, what would you say this is? What would you say that is?
Would it be 5 to the power of 6?
How'd you get that?
I did 3 times 2.
Yes. So in this case, 3 times 2, just to show the longhand of why this is the case. 5 to the power of 3 times 5 to the power of 3. So it comes in by itself, giving you 5 to the power of 6. Okay. Next page then. Next slide. What about this? What is that as a power of 5?
Would it be 5 to the power of 35?
Why is that?
I divided 25 by 5 and then I multiplied 7 by 5.
Okay. Got to be very careful. What is 25 as a power of 5?
5 to the power of 2.
So if we rewrote 25 as 5 squared, you see how we've reduced it to a problem that we already knew in the past.
Yeah.
And what does that become?
5 to the power of 14.
That's it. So we've got a few basics here. So this, I think, should be enough to now equip us with answering questions like this. Right, it looks like it's going to be a bit of a jump, but it's not so bad. Right, if I've got 5 to the power of 3x plus 1, all in the power, is equal to 5 to the power of 7x minus 1. I'm just going to give you a minute to have a think about how you would do this. I'm just going to charge my device as well whilst we do that. And then we'll come back and then you can let me know what ideas you have. Is that all right?
Yeah, sure.
Cool. Okay, so ideas.
Would it be 5 to the power of 10x?
Well, with this question, we're trying to work out what x is. So we've been told 5 to the power of 3x plus 1 equals 5 to the power of 7x minus 1. So if we've got that 5 to the power of something equals 5 to the power of something else, then what this actually means is those two powers are the same as each other. So what we can say is that 3x plus 1 is in actual fact equal to 5 to the power of 7x minus 1. Does that make sense?
Yeah.
Oh, wait, hold on. No. Whoa, that should not make sense. What I meant was this, just 7x minus 1 by itself. And then to solve this, we can take away 3x from both sides. So we get 1 equals 4x minus 1. And then adding 1 to both sides, we get 2 equals 4x. And dividing both sides by 2, we get 2 over 4 equals x. Or simply x equals a half. Okay, so let me give you another example then for you to try. So have I got this one? And then we have a minute to do so. Okay, so was this one okay?
Yeah, I got x equals -2.
Okay, let's have a look. So 4x minus 7 equals 9x plus 3. Take away 4x from both sides, we get minus 7 equals 5x plus 3. Take away 3 from both sides, we get minus 10 equals 5x. Divide by 5, yes, minus 2 is equal to x. Nice. Okay, let's go on the next slide. If I have 5 to the power of 7x plus 1 multiplied by 5 to the power of 5x, take away 12, is equal to 5 to the power of 8x plus 20. With this kind of question, we will just want to make sure that we can simplify the left-hand side. So how might we be able to simplify the left-hand side?
Add the two indices on the
There we
left.
go. That's it, yeah. And what does that simplify to?
Um, 12 12x minus 11.
5 to the power of 12x minus 11. So, yep, because we're multiplying, we can add the indices, and that is equal to 5 to the power of 8x plus 20. And then it becomes the same thing as before. So we can say 12x minus 11 equals 8x plus 20. Taking away 8x from both sides, we get 4x minus 11 equals 20. Adding 11 to both sides, we get 4x equals 31. Dividing both sides by 4, we get x equals 31 over 4. Is that okay?
Yeah.
Cool. And I'm going through this quite quickly, so let me know if you want me to slow down at any stage. Right, this one's a bit of a tougher one. Bit more work to do. Okay, so I want you to have a think about some of the previous questions we've done, where the links are, and how we can simplify all of this. And just to help you out, both the left-hand side and the right-hand side can simplify. So, yeah, but I'll give you some time to think. Cool. Just checking in. How are you getting on?
I made 25 to the power of x add 3 into 5 to the power of 2x add 6.
Oh, nice.
And 25 to the power of 7x minus 1 into 5 to the power of 14x minus 2.
Nice. Yeah, let's just really hone in on why that is. So 25 is 5 squared. So we've got 5 squared to the power of x plus 3 multiplied by 5 to the power of 2x minus 1. And then this is 5 squared to the power of 7x minus 1. Then we've got 5, and then multiplying the 2 by x plus 3 is like an expansion of brackets. 2x plus 6 multiplied by 5 to the power of 2x minus 1 is equal to 5 to the power of, 14x minus 2. Yeah, good stuff. You've recognized what's going on. So from here, where do we go?
Do we add the two indices for on the left hand side?
That's it. Perfect. And what does that become?
4x add 5.
Yes. 5 to the power of 4x plus 5. And that equals 5 to the power of 14x minus 2. And then from here, of course, it becomes our equation, which I'll let you have a go at. Unless you've already got an answer.
Would it be 0.7 equals
That
x?
sounds right. So 4x plus 5 equals 14x minus 2. Take away 4x from both sides. We get 5 equals 10x minus 2. Add 2 to both sides, we get 7 equals 10x. Divide both sides by 10. 7 over 10 equals x. Or indeed, as you said, 0.7. Cool. Okay. That is it. Right. What about this? Well, actually, we need to learn some new laws of indices. Okay. I'm going to ask you some questions. If I had 2 to the power of 3, what is that? 2 to the power of 2, what is the... This is on slide 5. So, yeah, what is the answer to 2 to the power of 3?
8.
Mm-hmm. What about 2 to the power of 2?
4.
2 to the power of 1?
2.
Nice. What do you think 2 to the power of 0 would be?
1.
Yes. Why do you say 1, by the way?
Um, I'm not too sure.
That was some very intuitive... I don't know. Your guessing must be really good then. I don't know. You must get really lucky when you guess.
We learnt it at school, but I can't remember why.
Oh, okay. Well, let's just imagine that you're following the pattern of what's going on here. We're going from 2 to the power of 3 to 2 to the power of 2 to 2 to the power of 1. How are we generating each term? What consistent rule are we using to get from term to term?
We're taking away 1 from the indice.
Okay, taking away 1 from the power, and in the actual answer, how does that result? To get from
We're
8 or yeah, go on.
taking away half of the previous change.
Okay, taking away half of the previous change. Is there another way to say that where it's one operation?
Taking away halves.
Rather than taking away halves, what's another way of saying taking away halves?
Halving.
Yeah, halving, dividing by 2. In this case, anyway. So using that pattern, if I took it another step, what would this be? Still following that pattern of dividing by 2.
A half.
Yes, it would be half. And if I went again,
A quarter.
nice. If I went again,
An eighth.
yep. And if I went again,
A 16th.
yes. What about if I went again?
1 over 32.
Very good. Yeah. And so on. It just keeps going down like that. Okay. So, what about now if I were to go... In fact, let's generate another one. So next page, you can use the same logic as the previous page. Could you give me the answers to these?
Would 3 to the power of minus 2 be 1 over 9?
Yeah, it would indeed. And 3 to the power of minus 3.
1 over 27. No, wait.
Yeah,
Yeah.
You're right. Mm-hmm.
And the last one would be um 1/81.
Perfect. Perfect indeed. So now the question is, how might we generalize what if I wanted to say 3 to the power of minus x? Is there another way of writing 3 to the power of minus x without the negative power?
1/3x.
1 over,
3x.
when you say 3x, what do you actually mean?
3 to the power of x.
Yes. Perfect. Yeah. 3 to the power of minus x is indeed equal to 1 over 3 to the power of x. So yeah, generalized. Okay, so that being said then, if I have this as an equation, suppose I had this. Or, yeah. So with this, applying the same logic, well, 3 to the power of x just is what it is. 1 over 3, we can change that to 3 to the power of minus 1. To the power of 2x minus 1, which is equal to 3 cubed. And then we take it from there. 3 to the power of x multiplied by 3 to the power of, so then the minus 1 gets multiplied with the 2x, which gives you minus 2x. The minus 1 also gets multiplied with the minus 1, which is plus 1, which is equal to 3 to the power of 3. Adding the powers, you get x minus 2x is minus x, so 3 to the power of minus x. X plus 1 is, sorry, we just have the plus 1, because we're adding the powers. And then we get 3 to the power of 3. So indeed, minus x plus 1 is equal to 3, which means that minus x equals 2. So therefore, x equals minus 2. Any questions there?
No.
Cool. So, that being said, that being said, okay. By of course considering powers of 3, how might we solve this? Let me know when you think you've got an answer.
I think I have an answer.
Okay. What do you think your answer? Well, what is your answer?
X equals 4/10.
X equals 4 over 10. Okay. So let's see. So how did you start off? What kind of things did you do?
First, I changed 1/27 to 27 to the power of 1. Minus 1, sorry. Uh,
Okay.
yeah.
Mm-hmm.
And um, then I did 27 to the power of 1 multiplied by 4x minus 1, and I kept everything else the same.
Ah, okay. So 3 to the power of 2x. So like this, 27 to the power of minus 4x plus 1.
Yeah.
Okay. So minus 1 times 4x minus 1 times minus 1. Mm-hmm.
Then I changed 27 to 3 to the power of 3
Okay.
and did 3 to the power of 3 times um well, I did 3 to the power of 3 and then minus 4x add 1. So I multiplied the two indices,
Mm-hmm.
which got me 3 to the power of minus 12x add 3,
Okay. So 3 times minus 4 is minus 12x, or 3 times minus 4x is minus 12x. And then 3 times 1 is 3. Yep, I am with you.
then I added the first two indices,
Okay.
which gave me 3 to the power of minus 10x add 6,
Yep, so 3 to the power of, so 2x minus 10x, because you're multiplying, you're adding the indices. 2x minus 10x is minus 10x. 3 plus 3 is 6.
and I changed 9 to 3 to the power of 2.
Nice. So instead of writing 9, we put 3 squared. Yep.
Then I took away the two threes and did minus 10x add 6 equals 2,
Okay, yep. So the indices are going to have to be the same as each other. So minus 10x plus 6 equals 2. Mm-hmm.
which gave me minus 10x equals minus 4.
Yep,
I,
taking 6
yeah,
from both sides. Mm-hmm.
which was 10x equals 4, and then x is 4 over 10.
Yes. So 10x dividing both sides by minus 1, 10x equals 4. So x equals 4 over 10. Nice. Yeah, you nailed that. Yeah, everything you said was spot on. One thing you could have done um, was just go straight into saying that 1 over 27 at this point here, could have said that 1 over 27 is just the same thing as 3 to the power of minus 3. That just would have made it a little bit quicker for the steps. But regardless, the way you did it was fine as well. But very good. Okay. Mm, all right. Let's take this as an example then. If I have 9, next slide, 9 to the power of a half multiplied by 9 to the power of a half, what is that equal to? Using the laws of indices that you know. You're muted, I think. Oh,
9 to the power of 1.
9 to the power of 1. Yeah, because a half plus a half is equal to 1. So 9 to the power of 1. Or just the same thing as 9. So if that's true, then based on this question and this question alone, you've got something and you've multiplied it by itself and it's giving you 9. What does that mean 9 to the power of a half is?
I'm not sure.
Well, if we've just done 9 to the power of a half, multiplied by 9 to the power of a half, and our answer was equal to 9, you've taken something, you've times it by itself, and your answer was 9. What number multiplies by itself to give you 9?
3.
So 9 to the power of a half must be equal to
3.
It must be. Has to be. That's it. It's got to be. Let's just take this example with, say this. So what's this equal to?
25 to the power of 1.
Yep, which is the same thing as,
25.
yep. So what must 25 to the power of a half equal?
5.
It must be equal to 5. Are you starting to get a gist of the pattern as to what to the power of a half means?
Yeah.
What do you think it means?
It's the square root.
Perfect. So in general, something to the power of a half is equivalent or identical to the square root of that something. That's what that is. So if you're interchanging between those two things as powers, that's what you'd get. So if I had this 2 to the power of x plus 3 multiplied by the square root of x to the power of, no, not square root of x, the square root of 2 to the power of 6x minus 4 divided by 4, and that will equal to 8 to the power of x minus 1. Here, what we can do is simplify. So we have 2 to the power of x plus 3, which stays as it is. The square root of 2, we know, is 2 to the power of a half. It's the same thing as that. And that is being raised to the power of 6x minus 4. And that's all being divided by 4, which is 2 squared. And we've got 8, which is 2 cubed. And that's being raised to the power of x minus 1. Then we can simplify things even further. So 2 to the power of x plus 3 multiplied by 2 to the power of, so a half times 6x is 3x, so it's a half of 6x. A half times minus 4, or a half of minus 4, is minus 2. That's all being divided by 2 to the power of 2. Then you've got 2 to the power of 3 to the power of x minus 1. So we can multiply the powers there. 3 times x is 3x, so it's 2 to the power of 3x. 3 to the power of minus 1 is minus 3. And there we go. Now we can simplify even further. So the top part becomes 2 to the power of, so x, so adding the powers because we're multiplying, x plus 3x is 4x. And then the 3 minus 2 is plus 1. And that's all being divided by 2 squared. And that's equal to 2 to the power of 3x minus 3. And then we've got there 2 to the power of 4x plus 1 divided by 2 to the power of 2. Using our laws of indices there, we subtract. So 4x plus 1 take away 2 gives you 4x minus 1. So 2 to the power of 4x minus 1. And that equals 2 to the power of 3x minus 3. And we've reduced that to, again, one of those other equations that we can solve. Is it making sense so far?
Yeah.
Nice. And then put the powers equal to each other. We get 4x minus 1 equals 3x minus 3. Take away x from both sides. We get x minus 1 equals minus 3. Add 1 to both sides. We get x equals minus 2. That's a question like that. Now it's my turn to show you one, and for you to have a go. This is going to be like an ultimate question, which I think you'll be ready for. So here it is. So there you go. Looks horrible and complicated, but yeah. But I think you got this.
I think I've got an answer.
Ooh, okay. I see you working hard, diligently. What do you think your answer was?
I got minus 1/3.
Minus a third. Okay. Let's see. Let's see. What's the verdict? Okay, so let's do this. So, how did you? What steps did you take?
First, I changed the square root of 2 to 2 to the power of a half,
Mm-hmm.
all to the power of 8x, add 20,
Mm-hmm. What else did you change?
and I changed 8 to the power of 8 squared, add 2 to the power of x minus 1.
Mm-hmm.
I changed that to 2 to the power of 6 times 2 to the power of x minus 1,
Uh-huh.
which was 2 to the power of x add 5.
Yep.
And um, then I changed 2 to the power of a half to the power of x squared, sorry, x 8x add 20.
Mm-hmm.
I changed it to 2 to the power of 4x
Mm-hmm.
add 10.
Mm-hmm.
And I changed 8 to the power of 4x minus 1
Yep.
to 2 to the power of 12x minus 3,
Yep. Sounds good.
and 16x to minus 1, 16 to the power of x minus 1
Mm-hmm.
to 2 to the power of minus 4.
Yep.
Then I simplified it, which gave me 2 to the power of 19x had 7 over 2 to the power of minus 4, which equal 2 to the power of x at 5.
Ah, wait. I think you might have missed a little thing. So with the 16, well, let me just write this part first. With the 16, you had 2 to the power of 4, and then because it was 16 to the power of x minus 1, you had you changed it to what?
To 2 to the power of minus 4.
And then with the x, what did you do with the x?
Um, would it be 2 to the power of 4x minus 2 instead?
2 to the power of 4x minus 4, because it's 2 to the power of 4, which is 16, and it's all being raised to the power of x minus 1. So when you expand that bracket, it's going to be 2 to the power of 4x minus 4.
And then that would be 2 to the power of 15x as um, add 11.
Cool. Let me just run through the steps of simplifying everything before you do the division. So you've got 8 squared, so you've got that's 2 to the power of 3 to the power of 2 multiplied by 2 to the power of x minus 1. Then we have 2 to the power of 3x, 2 to the power of, so 3 times 4x is 12x, 3 times minus 1 is minus 3, and then we've got 2 to the power of a half times 8x is 4x, a half times 20 is 10, and that's all divided by 2 to the power of 4x minus 4. And then on the right hand side, we've got 2 to the power of 3 times 2 is 6, multiplied by 2 to the power of x minus 1. Okay, so from here, when we're simplifying, the left hand side, you were saying simplifies to, so 3x plus 12x plus 4x is 19x. You said this before. 2 to the power of 19x minus 3 plus 10 is plus 7. And that's all divided by 2 to the power of 4x minus 4. And that equals 2 to the power of x plus 5. And then the next line.
I did 2 to the power of 15x
Mm-hmm.
my minus 6 equals 2 to the power of x add 5.
So how did you get the minus 6? Sorry.
Oh, 7. It should be 3. Add 3.
Why?
Add 7 minus 4.
So remember, 7's at the top, minus 4's at the bottom. You're dividing, so therefore you're subtracting. So it's 7 minus minus 4.
So would it be add 11?
Yes, indeed. Add 11 indeed. And that would give us 2 to the power of x plus 5. And we've now reduced it to something really nice.
Would the answer be minus 6 over 14?
Sounds good. So we've got 2 to the power of 15x plus 11 equals 2 to the power of x plus 5. So we're going to say 15x plus 11 equals x plus 5. 15x plus 11 equals x plus 5. Then taking away x from both sides, we get 14x plus 11 equals 5. Taking away 11 from both sides, we get 14x equals minus 6. Dividing both sides by 14, we get x equals minus 6 over 14. Was that what you said?
Yeah.
Yes. Lovely stuff. So, yeah, we end up getting a different answer. So, now, to be fair, I made this question very, 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 very excessive. But the point there is, I'm sure you now remember those index laws.